Okay. So dependent and independent sources. So independent voltage sources. First topic. What is independent voltage source? It is the source which is characterized by terminal voltage and which is completely independent of the current through it. That means, that means if there is any source, see the figure, you can see in the figure there are three figures which is representing the voltage sources, and then then if this network demands, suppose this is the network and it demands 1 ampere of current, it has to deliver 1 ampere of current from positive terminal. If it demands 2 amperes of current, it has to deliver 2 amperes of current from the positive terminal. Like that, this voltage source, independent voltage source, is unaware of the amount of current that is delivering from its positive terminal. That we are calling it as a independent voltage source. Independent voltage source. So this voltage source is represented by a circle, and positive and negative are written, indicating that from the positive terminal the current may enter or leave. 90% the represented as current is leaving the positive terminal. Current is represented with a at the positive terminal, leaving from the positive terminal. Okay, and Vs represents the magnitude of the potential or voltage of the source. Vs may be 10 volts, 20 volts, 30 volts, or 40 volts, like that. The voltage represents the potential of this source. That means it can deliver at this potential. What is this 10 means? This voltage source can deliver at a potential of 10 volts, or this voltage source has a potential of 10 volts. This voltage source has a potential of 20 volts or 30 volts. Like that, the magnitude represents the potential of the source. The potential of the source. So in this we have an ideal source. An ideal source. We define an ideal source. An ideal source is nothing but, as I told you, the amount of current is independent of the voltage source doesn't know how much current it is giving, but for every voltage source there is a limit for the current. There is a limit for the current that is delivering. But an ideal source would theoretically deliver infinite amount of energy from its terminals. Infinite amount of energy. What is energy? Energy is nothing but E is equal to V into, that is the potential, into the current, into time. E is nothing but the potential into current into time. That means an ideal source, whether it is a voltage source or a current source, will deliver an infinite amount of energy from its terminals. That is called an ideal source. But ideal source never exists. But for our convenience of doing the problems, we assume that we have taken an ideal source. Okay, while doing the problems, we will assume that it is an ideal source. But ideal source does not exist. But for problematic purpose, we are dealing with ideal sources. So an ideal source is nothing but how this source is represented: a positive terminal and when with a negative terminal. Okay, upper terminal is positive and lower terminal as negative. Okay, that means the upper terminal is positive with respect to the lower terminal. Okay, the upper terminal is positive with respect to lower terminal. That means if it is a 10 volt source, the upper terminal is at a higher potential with respect to low negative point of a potential of 10. If I write 10 volts here, what is the meaning involved in it? The meaning involved in it is the positive terminal is at a potential of 10 volts, 10 volts compared to the negative terminal. So if it is given 10 volts, the negative terminal should be given 0 volts. That means the potential difference between positive and negative is 10 minus 0, that is equal to 0 volts. Sorry, 10 volts. So what is the potential difference? Potential difference is 10 minus 0, that is equal to 10. If I write here 10 and if I write here 5, if I write, then what is the potential difference? What is the potential difference?
5.
If I write here 10, here 5, 10 minus 5, that is 5 volts. The potential difference is nothing but VA minus VB. Suppose it is a terminal, if it is A terminal and it is B terminal, then what is the potential difference? Potential difference is VA minus VB. VA minus VB. So this is about your voltage source, independent voltage source. The name itself indicates that it is independent of the amount of current drawn from the by the network. Okay, the network will draw amount of current that is not known to this voltage source. It will deliver what amount of current the network demands, that amount of current it has to deliver. Okay, that is called independent voltage source. That is called independent voltage source. Next, independent voltage source with a constant terminal voltage is often termed as independent DC voltage source and can be represented by either of the symbols shown in the figure A and B. See here in the figure A, we have a voltage source. In the figure B, we have voltage source. In figure C, also a voltage source. Okay, but A and B are called DC voltage sources. These are called DC voltage source, and this is AC voltage source. The difference between AC and DC I'm going to tell in the next class. Okay, but for time being, you assume that there are two types of sources. One is AC source and another is DC source. Generally, DC source is represented with a symbol, sinusoidal symbol, with a sinusoidal symbol inside it. If you represent a sinusoidal symbol inside it, then it is called an AC source. AC source. So how many types of sources are there? There are two types of voltage sources. One is DC voltage source and AC voltage source. And these are independent voltage sources. These are independent voltage sources. Independent DC source and independent AC source. Okay, like that we have to name them. Next, independent current source. Independent current source. Independent current source. Okay, the independent current source is nothing but it is completely independent of voltage across it. It is completely independent of voltage across it. Suppose this is your current source. If this is your current source, it is also represented with a circle and an arrow inside it. What is the indication of arrow? That is, arrow indication is nothing but it is the direction of current flow. It is the direction of current flow. If I write IS here and if I say it is 5 amperes, if I say it is 5 amperes, that means 5 amperes of current will be coming across by this source. So it will give how much current? 5 amperes of current. And if I measure the voltage across this, if I measure the voltage across with a voltmeter, this is a meter which measures the voltage or potential across this voltage current source. Okay, this may vary. Sometimes it will be 2 volts. Okay, sometimes it will be 3 volts. Sometimes it will be 10 volts. That means how much voltage may be across these terminals. Okay, it has to give the designated amount of current. If I say 5 amperes, that means it has to give 5 amperes of current irrespective of the voltage across the terminals. Of the current source. Hope you have understood this. This point is very important. What is an idea? Current source? A current source is nothing but which will deliver a fixed amount of current irrespective of or independent of voltage across it. What is voltage source? Voltage source is deliver a constant potential value and it is independent of amount of current drawn by the network from the source. Okay, so what is the difference between voltage source and current source? In voltage source, what is fixed? Potential is fixed. Suppose if I write 10 volts, then this voltage 10 is fixed and amount of current I from this is varying. Okay, it will vary. Here IS is fixed. Here current is fixed, that is 5 amperes, and the voltage across this current source will be varying. Okay, voltage across the current source will be varying. So this is the voltage source. This is the voltage source. This is represented with positive and negative, and this is the current source. Okay, there is no positive negative signs here because the arrow indicates the direction of the current. Okay, the arrow indicates the direction of the current. Hope you have understood what is voltage source and what is current source. Hello class.
Yes, sir.
Yeah. So shall I go for the next slide?
Okay, sir.
Sir. Can anyone repeat what is voltage source and what is current source?
In voltage source, potential is constant and current is varying. In current source, current is constant, potential is varying.
Okay, very good. That is the simplest explanation. Okay, simplest way to remember the concept, but thing is that we have to explain elaborately. Okay. While writing in the
Yes.
examination, we have to elaborate the answer. Okay. Next, dependent sources. Next, we'll go for dependent sources. What is dependent source? What is dependent source? See here, there are dependent or control sources. They are called dependent or control sources. Why they are called dependent or control sources? Because the magnitude of these sources depends upon some other constant. Some other constant. See here, A is a current controlled current source. It is a current source because arrow is there. So compulsory it is a current source. Second also current source. Okay. And since it is positive and negative, these are called voltage sources. So current source, voltage source, and voltage source. But see here, the magnitude depends upon K into Ix. K into Ix means some constant into current. So it is controlled by the current Ix. That's why it is called current controlled current source. Why it is called current controlled current source? Because the magnitude. So independent voltage sources are represented with a circle, and these are represented with a diamond shape. Okay, these are represented with a diamond shape. And one more thing, I can replace this controlled with a term called dependent. I can replace this controlled with a term called dependent. So current dependent current source, or voltage dependent current source, voltage dependent voltage source, or current dependent current source. That's why these are called dependent sources. So the magnitude of these sources depends upon some other value in the network. What is this K into Ix? K into Ix is not this value. Actually, it is somewhere in the network. Suppose this is connected to a network, a huge network like this. Okay, so Ix may be the current flowing in this network. Okay, suppose Ix is equal to 6 amperes. If suppose K is equal to 2, then what is this magnitude? K into Ix, that is 2 into 6, that is equal to 12. That is 12 amperes. That means this current source will give 12 amperes. Suppose Ix changes to 7 amperes. Then what is the magnitude? 14. Then 14.
714.
Yeah, 714. If it goes to 10, then it is
20.
20. That means the magnitude of this source is depending upon the some other value in the circuit. That's why it is called dependent source. This is also dependent source, and these four are dependent sources. Hope you have understood until now.
Sir.
Yeah. So independent and dependent sources. This gives a summary of all the sources in a single statements. Okay, the same which I have explained. This gives the definition of all the sources in a single statement. Okay, in the examination you can write in this fashion also. So ideal independent voltage source. So what is ideal independent voltage source? Which maintains same voltage regardless of amount of current that flows through it. Its value is either DC or AC. Okay, what is independent voltage source? It is maintains the same voltage regardless of amount of current flows through it. Okay.
It is either
Uh-huh.
constant or
Yeah. Next one is ideal independent current source. Ideal independent current source maintains the same current regardless of voltage that appear across its terminals. Its value is either DC or AC. So this is the second definition. This is the first definition of independent voltage and current sources. Next, dependent voltage source. Its value depends upon the other voltage or current elsewhere in the circuit. Hence, the constants Ki or K2 is the resistance and is defined as a linear divisors. When denoted as K1 into V, it is referred as voltage controlled voltage source. And if it is represented with K2I, it is referred as current controlled voltage source. This is a voltage source, but it is whether it is a voltage controlled or current controlled depends upon this K1 into V or K2 into I. K1 into V or K2 into I. Okay, that is what it is here. It is being explained. Okay, when it is dependent with denoted with K1 into V, it is a voltage controlled voltage source. If it is denoted with K2I, it is a current dependent or current controlled voltage source. Similarly, dependent current source. Its value depends on other current or voltage elsewhere in the circuit, in the same circuit. Okay, in the same circuit. K3 into I refers to current controlled current source. K4 into V refers to voltage controlled current source. Voltage controlled current source. These two values decides whether it is a current controlled or voltage controlled current source. So this is a dependent current source and this is a dependent voltage source, and these two are independent sources. These two are independent sources. Am I clear up to now?
yes, sir.
Yes, sir.
Yeah. Now, here is a small problem for you based on the dependent and independent sources. Here it is written V2. Here it is written V2. Okay. Suppose if V2 is equal to 3 volts, if V2 is equal to 3 volts, what is the magnitude of this dependent source? Where is the dependent source in this? Here it is the dependent source. The only one dependent source is there. Okay. And here they are asking what is VL value. What is VL value? Okay. What is VL value? So since these two are parallel connected, what is the voltage across this source will be the same as the voltage across this element. Okay. So if you